Okay, so then, of course, we get to what equations do we use to solve these? And when we were in 2D, we had 3 equations. When we're in 3D, we actually end up with 6. I think the sum of the forces are pretty clear because we already did that. Sum of the forces in the x, sum of the forces in the y, and sum of the forces in the z. For the moments in 2D, we only had one equation because all of our moments were going to be in the z direction, right? But now that we're in 3D, the moments aren't just in the z direction. They're in any direction, right? So what we're going to do is we're actually going to pick the point we're interested in and set it up as an origin, okay? That'll be an origin, and then we'll say the sum of the moments about the x-axis at that origin are going to be equal to 0. The sum of the moments about that y-axis are going to be equal to 0. And the sum of the moments about the z-axis are going to be equal to 0. So we end up with 6 equations of equilibrium that we can use. So how many unknowns can we solve for? 6. Yay! Okay. So let's do one of these. This is 577. It says a vertical force of 80 pounds acts on the crankshaft. The bearings A and B are properly aligned and exert only force reactions on the shaft. Okay. Determine the horizontal equilibrium force P that must be applied to the handle. Determine the X, Y, Z components of reaction at the journal bearing A. Determine the X, Y, and Z components of reaction at the thrust bearing B. Whew. That was a lot of information shoved into, what, 3 or 4 small sentences. So we should go through it step by step and make sure we understand everything it's telling us. So I'm going to start with my givens. And it also says something else. It says the bearings A and B are properly aligned and exert only force reactions on the shaft. So I'm just going to write that for now as A and B are aligned. We'll talk about what that means in just a second. And we're supposed to find the XYZ components of reaction at journal bearing A. That's another given. B is thrust bearing. And we're supposed to find AX, AY, AZ, BX, BY, BZ, and P. Okay, that's a lot of unknowns. So what's the next step? Now that I got my given and find down. Free body diagram. Go ahead and draw a free body diagram. Okay, let's go ahead and do the bearings together, one at a time. And if we do bearing A first, what type of bearing is A? Journal. Okay, if A is a journal bearing, which forces do I need? I need AX and AZ, very good. And what moments do I need? The moment around X and the moment around Z. Because if you look at that, I could spin it around Y, but I couldn't spin it about the other two. So I'm going to put a moment about X and a moment about Z. Okay. So B is going to be very similar, but what else do we add? Very good, an additional force on the y-axis. So we're going to have our BZ, we're going to have our BX, but we're also going to have our BY. And then we're going to have the moment about the X. We're going to have our moment about the Z-axis. Okay, so now how many unknowns do I have? 10. 10, okay. So when you have 10 unknowns, how many equations do I have? 6. Okay, so what do I do? Ah, darn. I can't do this. Ah, I give up, right? Okay, so there was another piece of information that we totally skipped over. The bearings A and B are properly aligned and exert only force reactions on the shaft. Okay, we got to take that into account. So when there's a single bearing, go ahead and let this one off again. When there's a single bearing, it's the only thing that keeps it from twisting. When we throw another bearing on there, now this bearing is going to have, I'm pushing down, so this bearing has an upward force, And this bearing has a downward force, but no longer feeling the moment. Okay? If it helps, you can even think of the bearings as being just slightly loose. Okay? The bearings are just slightly loose so that if there was a little bit of motion, it wouldn't kick in the moment support quite yet. So if there are two bearings, all we're going to feel is forces. If there's one, we're going to feel moments. That's what they're trying to say. They're trying to say that bearings A and B both lie on the y-axis, and those are both going to be aligned straight. So what do? We erase our moments. We erase the support reactions from our moments because those bearings are only going to apply force reactions. Now it says that really on top. It says bearings A and B are properly aligned and exert only force reactions on the shaft. So it's telling us to not put the moments on there. If there was a single bearing, you would put them on there. Okay, now how many unknowns do we have? 6. And how many equations? 6. All right. But what's going on? If you look at my find, I have 7. One of them is 0. Which one do we already know is 0 without any calculations? AY. We know that just from the text of the question, right? It says that A is a journal bearing. So we can already say that AY equals 0. Because journal bearings don't have any support along their axis. Okay, so now is when we start getting creative on problem solving. We could just jump right into this and we could just say, I'm going to do sum of the forces x, sum of the forces y, sum of the forces z, sum of the moments x, y, z. You would get the right answer. But what's going to end up happening is you're going to end up with some equations first that you can't solve directly. Maybe you'll have to do a system of equations. So what I suggest instead is to look at it and say, okay, well, if I were to do sum of the forces in the x direction, how many unknowns would I have? 2, bx and ax. Good. So I'm not going to do that one. How about the y direction? How many unknowns would I have? 1. So why don't I do that first? Okay, so sum of the forces in the y equals 0. What are my forces in the y? by. It must equal 0, because there's only one force. If I do sum of the forces in the z, how many unknowns will I have? 2. So I don't want to do that either. What equation might I want to do next? The moment about. Yeah, very good. So if we choose the y-axis, you'll notice the y-axis passes right through A and B, meaning that any of the support reactions at A and any of the support reactions at B don't create a moment about the y-axis. So let's do that one next. If you ever feel overwhelmed, like you have a question and you just don't know where to start, don't feel pressure to need to know everything I'm talking about right now. If you don't know where to start, just start. Sum of the forces in the x and start writing it down. Okay? Don't force yourself to always get the best one. But I do encourage you to start thinking about it and seeing if you can get an insight before even starting the math. So we do sum of the moments about the y-axis are equal to 0. Now for the moments about the y-axis, of course, ax, az, bx, bz, and by all create 0 moment because those are all on the y-axis. The 80-pound force is going to create a moment. I need this distance, which would be the perpendicular distance from the y-axis to that force, and that shows us 10 inches. I'm then going to go and put my thumb in the positive direction of the y-axis. I'm going to point my fingers along that green line that I just drew. Would the 80 pounds tend to curl them back or bend them back? So it would be a negative force. So I'm going to say negative 80 pounds times the distance, which is 10 inches. Okay, now we're going to do the same thing for P. The perpendicular distance we're looking for is the green, what I just colored in green right above the hand, and that's given as 8 inches. And do the exact same thing, point my thumb along Y, my fingers along that green. Would that be positive or negative? It's a positive. So we multiply P by 8 inches, and that's equal to 0. Because there's no other forces making a moment about that. So P would be equal to 80 pounds times 10 inches over 8 inches, which is 100 pounds. Okay, so we have 3 unknowns already. We have AY, BY, and P. But you're right, we can do the sum of the moments about the X. Is there another one we could choose? Sum of the moments about the Z. Either one of those is going to give us a single equation, single unknown. Very good. So we could do sum of the moments about X. P is in the X direction, so it doesn't give us anything. The 80 pounds does. So we would need to find the distance. I'm going to erase the green ones that are up there. We would need to find this distance, which is given as 14 inches. And I'm going to put my thumb in the direction of the x-axis. I'm going to point my fingers towards the 80-pound force along that green line. And you can see it would tend to bend them backwards, bend my fingers back, which makes that negative. So that would be negative 80 pounds times 14 inches. And then we would do BZ. BZ is the only other force that creates a moment about the x-axis. Right? Because BY would pass right through the x-axis. The line of action of BY would pass right through the x-axis. BX is in the x direction, so it can't create a moment about x. And P is also in the x direction. Okay, so we're just going to add BZ times its distance, which is given as 28 inches, equals 0. So BZ equals 40 pounds. We've got 3 more. So the next, I already heard someone say sum of the moments about Z. Let's do that next. Go ahead and try to calculate the sum of the moments about Z on your own or with your partner, and I'll come around and answer questions that you have. You should be able to solve for BX. Some of the moments about Z, there's just going to be 2 things that create a moment about Z, which are P and BX. So I'm going to point my finger my thumb in the Z direction, and my fingers will go towards P, and you'll see that it tends to bend them back. So that would be negative P times 10, which is a 6 times plus the 4. Then if we look at BX, I'm going to do the same thing. My thumb in the Z direction, my fingers towards BX. The arrowhead shows it would tend to bend them backwards. So that is negative as well, times 28 inches equals 0. So BX is equal to negative 100 times 10 over 28, which is negative, what, 35? 35.7. 35.7 pounds. Okay, then what do we do? Now we have all but 2, right? We still need AX and AZ. Those are the only 2 we don't have. Sum of the forces, good. This is where we go back and we do sum of the forces. We can say sum of the forces in the X is equal to 0. And we'll just have negative 100. That's our P plus AX plus BX, which is negative 35.7 pounds, equals 0. AX equals 135.7 pounds. Okay, you notice that AX, and this was a very good question I got right before the break. The question was, how do I know which way to draw AX and AY? Now, you can look at this one, and if you look at this one, if you see P is pushing in the negative X direction, you would expect AX to be positive to counteract that. And then, because of the twisting motion that creates, you'd expect BX to be the opposite way. That's what we found, right? BX is negative. That means it's pointing the opposite direction. AX is positive. However, I don't recommend in 3D, I don't recommend trying to make all the forces the way they go. It just gets too complex. What I do is I just put them in the positive direction of the axes, right? So I always draw AX and positive X. I always draw BX and positive X. Then at the end of my work, if I get a negative answer, I know it's going the opposite direction. I find that's easier. Do you have to do it that way? No. All you have to do is stay consistent. You have to make sure your free body diagram matches your map. Okay, and then one more step, we do sum of the forces in the z direction equals 0, and we're going to have AZ minus 80 pounds plus BZ equals 0. We've already calculated BZ, it was 40 pounds, so AZ is going to be equal to negative 40 pounds plus 80 pounds equals 40 pounds. Now, I kind of subtly introduced something here that we hadn't done yet, and that was finding moments in 3D using the scalar equations, right? We use all of these, to find all of these moments, we use scalar equations. We were using our right hand, and we were finding perpendicular distances. What's the other way to find moments? Vectors, good. So that's an option too. You can use vectors for this. Let me show you how you would do that real quick. Okay, so if we want to use vector notation to find our moments, what we're really going to use is the vector equation for moment, which is just the sum of all the moments as a vector is equal to 0. A single equation, but we actually get 3 equations out of it, right? So what that means is we're just going to have to look at each one of these forces and find its moment about point A. Because point A is the point we chose to find the moment about. So we have to turn them all into vectors. So we would say P equals negative P times I. We would say that 80, I'm just going to call this F for force. F is equal to negative 80 pounds in the K. Now the B, really I just say that B as a vector is going to be equal to bxi plus byj plus bzk. Okay. So then I'm going to go ahead and find the moment about point A of all 3 of those forces. So let's start with P first. I would say that moment of P is going to be equal to R crossed with F, which in this case is going to be the position vector from A to P crossed with the P vector. What's the position vector from A to P? Well, it's going to be in the YZ plane, right? So I can just jump into my cross product. If I'm standing at A and I'm walking to P, I'm going to go in the negative Y direction, 10. Negative 10. I'm not going to go anywhere in the X. In the negative K, I'm going to go 8. What's that? Negative 8, thank you. And then I put my P in, which is going to be negative P 0, 0. Okay, I'm going to find the moment of that. 0, 0 for the I. For the J, it's going to be negative 0 minus, and in the K, 0 minus negative 10, negative P. Okay, so then we just solve that out, and that's going to be 4 negatives is 8pj. 3 negatives minus 10pk. Okay, then we're going to do the same thing for the 80 Newton force. We're going to have RAF. If we're going from A to F, we're going to go negative. We're going to go positive J14. So this one is going to be the moment about the 80 force is going to be equal to RAF crossed with F. The R, I'm going to walk in the positive Y direction 14, and in the negative X direction 10, but nothing in the K. And my R is going to be negative 80K. Negative 10, thank you. This will be negative 80K. 0, 0. So I'm going to get 14 times negative 80 minus 0, I. J would be negative 10, negative 80 minus 0, J. And K is going to be 0, 0. Okay, then we have to do it for B. Now for B, we just need the position vector from A to B, which is just going to be in the j direction. So we'd go like this, I, j, k. Our position vector from A to B, so the moment for B is going to be equal to RAB crossed with the B vector. RAB is just going to be 0, 28, 0. And the B vector is just going to be BX, BY, BZ. Okay, so we do the cross product for this one. Be 28 BZ times I minus 0J plus K is going to be 0 minus 28BX. Add the i's, add the j's, add the k's. They all have to equal 0. Okay? So let's add all of that up to get my resultant vector. So I'd end up with, I have 3 vectors to add up, that one, and that one. So if I add up all the i's, I'm going to get 8p minus 14 times 80 plus 28bz equals 0. This turns out to be some of the moments about the x-axis. Notice I can solve for bz right there. Well, if I know p, I can solve for bz. Right? Okay. Then I'm going to do my j's. Some of the moments about the y-axis equals 0. The first one is, oops, I was wrong. The 8p's in the j, I just read it wrong. So I would end up with 80 or 800, negative 800j plus 8p equals 0. And that's where we solve for p. P equals 100, just like we got before. And then we would do some of the moments about z, which is just all the k components. Negative 10p minus 28bx. So we solve for p, we get 100, we plug it into the other two, we get bx and bz. That makes sense? It's the same thing, it's just you either do it with vectors or with scalars. It's your choice.